We've learned a lot, okay? So remember, if we have a central angle starts on the center of the circle and opens up on the arc. If you know the measure of angle theta and it's a central angle, isn't that equal to the measure of the arc?
Yes.
So if this is 30 degrees arc AC, the measure of arc AC is 30 degrees, correct?
Yes.
Yes, that is not the physical length though, right?
Right.
That's just the measure of the arc. Now if you have a central angle that opens up on an arc and I want the length, you've got to consider the radius times the theta. Where theta, since we're talking physical length, has to be in radians. How do you take something in degrees and change it to radians? You multiply by pi over 180, right? So 30 degrees times pi over 180, if this was 30, would be pi over 6. Because 30 over 180 simplifies to be 1/6. Do you understand that?
Yes.
So that's just the radian part. So then you do your radius times that. Then area of a full circle would be filling in this entire thing. Pi r squared. If you don't know that, you should be back in middle school because really, I'm not saying that to be mean, but like that really you should know the area of a circle, guys. Pi r squared. The circumference is the physical length around the outside of the circle, 2 pi r, and that's the full outside. The area of a sector. Remember, that means area of just a section of the circle, right? So you know area of a full circle, and I just can't stress this enough. Area of a full circle is pi r squared, right? So then it shouldn't be any harder to say, I know area of a sector. It's the section over the full circle, theta over 360 times pi r squared. You don't have to change theta, it does it in the formula. So then the next thing we learned, if you have a tangent line, it touches the circle once. If you drop a radius to a tangent line, it creates a 90-degree angle. And then we might have something that looks like this. Now if it's truly a 90-degree angle, it's truly tangent, and the Pythagorean theorem will match up, right? So a couple things will happen. If it says, prove the line is tangent or not, you don't know if that's 90 degrees. That's what you're going to find out, right? So you say, well, if it was 90 degrees, the Pythagorean theorem would work out, therefore I'll check it. And if it does check out, then yeah, it's 90 degrees. If not, then no, so it wouldn't be tangent. And you could, in the instructions, if it says, assume the line is tangent, you know for a fact that's 90 degrees. Does everybody understand that? Okay. Then we learned about an inscribed angle. An inscribed angle is different from a central angle. They have different rules. An inscribed angle starts on the outside of the circle and opens up on an arc. We know 2 times theta, 2 times the inscribed angle is equal to the arc. Or the arc divided by 2, or 1/2 times the arc, is equal to theta. Does everybody understand that? Go back and forth. And then we also learned that if you have a chord and you drop a radius at a 90-degree angle, it cuts the chord into 2 equal segments. Now remember, does that mean it cuts the radius into 2 equal segments? No, right? Okay, and then could I draw my own radius wherever I wanted?
Yes.
Yeah, right? Isn't a radius always the same as a radius? So you can draw it wherever you want to fit your needs. Does everybody understand that?
Wait, so the radius doesn't get cut in half?
Nope. Yes, good. So the radius isn't equal necessarily, but this chord is equal. Now let's say you're finding something down here. Well, that's not even in a right triangle. Has nothing to do with it, right? Aren't we using right triangles to solve this? So we would have to find this first, and then once you know that, you take the full radius minus that. Anyways, okay. Oh yeah. Then the equation to a circle is x minus h squared plus y minus k squared is equal to the radius squared. So keep that in mind. Okay, so I'm just going to do a couple examples. The rest of the time will be
What was that equation for?
Isn't that the equation of a circle?
Okay.
And in the equation of the circle, isn't this our center, hk? And our radius would be the square root of r squared, right? Radius, okay? Sweet. So the length of this highlighted arc. Let's find the length of an arc. First of all, you should know right off the bat which formula.
8 plus 2.
Oh dear. How do you find the length of an arc, guys?
Oh, it's pi.
That's circumference.
It's pi.
Okay, we're in trouble for this test tomorrow if you don't know this. Guys, what is the formula for the length? It's not for me at all. I'm mortified. What is it? Yes, anytime we're dealing with length, it's physical length. Guys, S is equal to R times theta. If you don't know that, you're not going to pass the test tomorrow. I'll tell you right now. Okay? So radius times theta. So S is equal to our radius, which is what? 7 times theta, which is what?
300.
And then can we leave it in degrees?
No.
No. Are you paying attention to what we're doing? Because we've done this like so many times, I'm blown away that nobody knew how to do it. Are we all good?
Yes.
Are you actually paying attention and internalizing what I'm doing? Okay. So then we gotta change that to pi, we gotta change that to radians. So I'm gonna say 7 times 300 times pi over 180, right? Now can't we just multiply straight across? So x is equal to, type it in, 7 times 300 divided by 180.
5 pi thirds.
7 times 300 divided by 180.
Oh,
11.6. And we change it back to a fraction, right? 35 pi thirds. Okay, so we get 35 pi thirds. The physical length from here to here is 35 pi thirds centimeters. So what if I wanted that answer, which I will, and the decimal answer?
just touch it.
Just type it in, right? 35 pi, use the pi key, divided by 3. So that, from here to here, was 36.6 centimeters. Does everybody understand the physical length? If I ever say length, you need to do the physical length, yes.
We need to do both.
I will specify, but it wouldn't hurt, would it?
No.
Okay. So find the length of an arc. What's the formula? Radius times theta. Okay, what's my radius?
Pi thirds.
What's, no,
Oh, sorry.
what's my radius? What's my theta? Pi thirds, so I have to change this one to radians. No, it's in radians, so isn't that one easy? S is equal to 4 pi thirds over 3, right? 4 pi thirds over 3. 4 pi thirds, that's what I meant to say. Questions?
4.2.
So that would be 4.2, whatever. Okay, 4.2. Okay. So what's the difference between this angle and this angle?
One central, one to...
One central and one inscribed. Okay, so if this is 30 degrees, is it an inscribed angle? It opens up on the arc from here to here, right?
50.
So what would that be?
60.
60 degrees, right? This times 2 is equal to this. Very good. So what about this one? Is this times 2 equal to this?
30.
No, that's a central angle. Central angles equal their intercepted arc. So this opens up on the arc from here to here, so what would this be? 30 degrees. Questions on the difference? Make sure you know the difference. Okay, so let's factor. It says rewrite this in factor form. Rewrite this in vertex form. Rewrite this in standard form. So look at this. This is not in factored form. Did I say solve? No, we're not solving it. We're rewriting in factored form. If you can't factor, I cannot let you move on next year. We will have a test, many quizzes, and I really can't move you on next year if you can't factor. So you might want to learn or just plan on not going on next year. So, factor. It doesn't factored form make sense to have it factored. Okay, so what's my A value? 1. My B value is? And my C value is 1. Okay, so there's nothing in common right here. So that's when we do A times C. Well, multiplies to be 1 and adds up to be -2, right? Factors of 1. 1 and 1, negative, negative. -1 times -1 is 1. -1 plus -1 is -2. So our factors are -1 and -1. So then, many of you do it the long way, which is fine. You drop and break. So I'm going to do it that way. So you drop down your n terms, right? Then you break down your middle terms. So your n terms drop down are x squared and plus 1. Then your middle term is -1x and -1x, right? Then you group the first 2 terms, the last 2 terms, then you factor. What's in common in this group? So then left is x minus 1, right? Then what's in common here?
Negative.
-1. There's a negative in front, we pull out -1, left is x. Then our safe haven's good, we factor that out. We factored out x minus 1, right? So then left was x minus 1. Now, if it said solve, we then set it equal to 0. But it didn't. It said rewrite it in factored form. Didn't we accomplish that?
Yeah.
So we're done.
How did what you said that's 0?
Set each of those equal to 0 on side.
X minus 1 is equal to 0.
If it was equal to 0 up here, isn't it equal to 0 down here? Since they're equal, just in different forms. Yeah, right?
So would you just house maxing?
There was no square rooting involved in this.
So it'd be 1 and 1.
Right. Okay, so vertex form. To do, this is in standard form, we're going to vertex form. You do that by completing the square, which is b divided by 2 squared. What's my b value, including the sign?
-2.
So -2 divided by 2 squared, which is -1 squared, which do not say is -1, you'd be wrong. Positive 1. Guys, by definition, -1 squared means -1 times -1. What's that? 1. Okay. So then we, what? Y? Okay. So then we insert that in right after BX, right?
Yes.
That's our square. This is our square. So we're adding that in after bx. X squared minus 2x. You add your square. If you add a square, you change it. So don't you have to really add a 0. So you subtract your square, and then we have our plus 1. Does everybody see where my fancy 0 was inserted? So that was 1 and 1. Then people from there say, well, what do I do? Well, remember, you group the first 3 terms in factor. You group the last 2 terms and add them up. So let's factor this. 1 multiplies to be 1 and adds up to be negative 2, right? Or we did learn that if you look back inside here, it's going to factor to be that twice, right? A binomial with that twice. So factors to be x minus 1 times x minus 1. Let's add those up. Negative 1 plus 1 is? 0. So plus 0. So our final answer would be x minus 1 squared. There's vertex form of that. Does everybody understand? Okay, so then standard form. It's in vertex form. This is in vertex form. Wouldn't we just multiply it out? Yep. So x minus 1 times x minus 1, and then we have plus 1. So we're going to do a distribute. X squared minus x plus 1 plus 1. So we combine like terms, x squared minus 2x plus 2. This is the standard form of this. They're equal. We haven't solved anything. We're just changing the forms. Does everybody understand that? Okay, sweet. It's all in the wording. Okay, the rest of the time's yours. And I gave you another example. It says, what equation has these solutions? So first of all, I'm going to ask you, how many solutions are we talking? 2. So what degree is our polynomial going to be? 2, right? 2, okay? And so what we're saying is, okay, so we have a polynomial of degree 2. Well, think about it. To get these, we had to have linear factors set equal to 0. So what linear factor was equal to 0 so that we got negative 1? Well, let's see. Let's make it equal to 0. So x plus 1 is equal to 0. Isn't that true if x is equal to negative 1? Yeah. So same thing here. We need our linear factor that gave us the value x is equal to 2. So that would have been x minus 2 is equal to 0. Minus 2, sorry. Now you say to yourself, okay, before we were able to split these apart and individually set them equal to 0, they used to be together, multiplied, and equal to 0. And then before we had them multiplied and set equal to 0, before we factored, they were all multiplied together and in standard form. So that's x squared minus 2x plus 1x minus 2 is equal to 0. Our polynomial that had those zeros is x squared minus x minus 2. There's our polynomial that had those solutions. We worked backwards, right? So we can go the other way. We could factor, solve, set them equal to 0, right? Okay, sweet.